Prominent controller packages come pre-wired and pre-programmed from the factory. I'm going to walk you through the process of starting up a package. The package we have here has a DACb controller on it, and with that controller we are going to be looking for the free chlorine. And with the free chlorine we also need to make sure we have a pH sensor to compensate for our free chlorine reading. We'll start off by going through the process of getting our flow set up correctly and then also preparing our sensors to read correctly. Then we will go into the controller and I'll walk you through showing you what wiring we have done from the factory and then show you what options that are in there to allow you to, in the field, add additional components. From there we'll go into the controller, we'll push some buttons, I'll walk you through all the menus to show you exactly what we programmed from the factory and then show you other options that are in there. And then lastly, we will do a calibration of our sensors so that they can be up and running accurately. Looking first at our flow cell, you can see all the way to the left we have an isolation valve. That would allow us to valve out the water so that we can access our sensors without water flowing all over the place. Next is a pressure regulator. And on that regulator is a gauge. Our amperometric sensors, in this case our chlorine sensor, is very sensitive to pressure. Too much pressure is going to affect our electrolyte in our sensor, so we'll talk about how that gets set up. After that we have a flow sensor. A flow sensor is very important if we are controlling directly from our DACb. It will tell us if we lose flow. It will recognize that in the controller and that will shut down all of our pumps that we're controlling directly from here. That way we are not pumping chemical into a stagnant line. So that is for safety. Next we have a place to put our pH sensor. Your pH sensor will ship loose. It is shipped in a holder, and in that holder there's going to be a liquid that keeps the sensor alive. So we will take that sensor off and thread it into our DGMA flow cell. You don't want to tighten that. You will risk the potential of cracking components here. Once we get this set up, we will have less than 15 psi of pressure in here. So we really don't need to crank down on our components because there's really not that much pressure in this flow cell. Once we get the sensor in there, we're going to find our pH sensor cable. It is a coax cable. It will screw onto the top. And then next to that is our chlorine sensor. Your chlorine sensor is going to be pre-wired into the controller. It is also going to ship in the DGMA cell. It does require that you pull it out and gel the electrolyte. So you will get a separate box with the electrolyte in it. You will need to go through the process of gelling up that sensor. And I'll show you a short clip here on what that process looks like.
So we're going to be sure that we don't have flow in our sample line. Loosen the compression fitting holding the sensor in place. Remove the sensor from its sample cell. Remove the membrane cap. I'm just going to place that there for the time being. Now this particular sensor has a very water-like electrolyte. We're going to fill that cap full. Be sure that there are no air bubbles down where the membrane is inside of the cap. Thread that cap back onto the sensor. Place the sensor back into its sample cell and tighten our compression fitting back in place. We can now start flow in the sample line after we've changed the electrolyte, or if we first installed the electrolyte. It takes several hours to get a true reading before we want to do our calibration. Some of our sensors have electrolyte that is a little bit more viscous, so to change or to add the electrolyte in that, again, we're going to remove that cap. We're going to fill that cap with electrolyte. Here you can see how much thicker the electrolyte is. We want to fill it again so there's no air bubbles. If there is an air bubble, that air bubble will migrate towards the top in time. We'll let that come to the top. Never put a screwdriver or any other instrument into the electrolyte. If you want to try to help remove the air bubble, use the sensor tip itself. We'll now thread that sensor back on. You'll see that the electrolyte will come out. Then we will want to wipe that electrolyte. Never wipe across the membrane itself. Now we can put this sensor into flow. It tends that the electrolytes take a little bit longer to energize, so you'll have to wait a little bit longer to do your calibration.
After you've gelled up your free chlorine sensor, your next thing after that is going to be a needle valve. That needle valve is going to be where we adjust the flow. Our chlorine sensor is very sensitive to the amount of water that is going by it and also the pressure like we discussed. So this is where we're going to adjust our float on our flow cell, and we'll discuss what that needs to be set at. And then lastly, we have another isolation valve, so we can lock the water in this and maybe move it to another place if we want to. Once we have our sensors installed, we need to set our pressure and flow. So what we're going to do is loosen up our flow sensor. And we're going to pull it all the way to the top and just loosely tighten it down. Once I've done that, I can introduce water into the flow cell. We want to come over to our pressure regulator. On the pressure regulator, on the adjusting knob, there is a nut there that helps lock that in place. You're going to want to loosen that. And we want to set our pressure so that it has less than 15 psi. That pressure would be what is being seen on our flow cell. So we're going to adjust that so it's not seeing any more than 15 psi. Once we have that adjusted, we can turn in our locking nut, and that will keep it in place so it doesn't work its way out. Next step would be adjusting our flow, and we're going to adjust that with our needle valve here. Ideally, we found that a good starting point is right around, there's a dash mark on here right around 12 gallons an hour. That is typically a good starting point. The more flow you have going past our ampermetric sensor, that will keep the cap cleaner, but it may also draw out that electrolyte faster. So you may have to replace the electrolyte sooner. The slower the flow is going through there, the longer the electrolyte's going to last in the cap, but your membrane may get fouled up depending on what's in the water. So a good starting point is around this 12 mark, and then you can play with that depending on what's in your water and depending on the actual application. You can either increase that or decrease that flow. Once we have that going by, we have water going by, their sensors need to be charged. A pH sensor typically is ready to go in maybe 30 minutes. A free chlorine sensor is going to take a little bit longer. The liquid in a free chlorine sensor is a little bit closer to water, so you may give it an hour or 2 hours to charge up. It does need to be in the presence of chlorine, so that water that is running by there does need to be some chlorine in that water to create that chemical reaction in there with that electrolyte. So that's the first thing we want to do, is getting water by here so we can get the sensors charged and up and running. Next, we're going to go into the controller, and I'm going to open the hood up and show you what some of the wiring looks like. We have our 4 screws loosened here, so now we're ready to remove the hood. On the hood, you'll see that there are 2 tabs on each side. That will allow us to park the hood here at the top so we don't have to hold on to it. It gives us easy access into the actual DACb here. All of our controllers, whether it's a DACb or an Aegis 2, they have those tabs so you don't have to just leave the hood of the controller just dangling down. First, I want to walk you through what sensors and what wires we landed here from the factory, and then we'll backtrack and show you what all the other open slots are used for. The first wire we come into right here is landed into DI1. That is a digital input. That wire we can trace back, and that goes to our flow cell. So that is our flow sensor. That sensor is a go, no-go device, so it's telling me whether or not I have flow or don't have any flow at all. So these digital inputs, you actually have 7 of them. You have DI1, 2, 3, 4, and then up top you have 3 more, so that's a total of 7 digital inputs. They can be used for float switches. They can be used for instance, the relay output on one of our prominent pumps that just gives us a closure. We could take that into the controller and do what we want with it. We can also bring in a water meter that sends out contacts. That water meter would allow us to do compound loop control, which would give us much tighter control on our process in the injection of chemical. So you do have 7 slots for that. Next thing we see wired up here is on this card that's raised out a little bit. We do have different options for cards. In this particular case, we have a millivolt, milliamp card. So on the left side of that card is where we bring our pH sensor, and that pH sensor is sending the controller a millivolt signal. So we land the shield underneath this clamp here, and then the actual wire to the controller goes up into the terminal above it. Also on here, we're not using, you can see there's a jumper here. That is a liquid potential. So if there is any disturbances in the water, stray voltage, if there's a lot of big motors or drives in the actual area where this controller is installed, that millivolt signal may be interfered with by that interference from those components. We can actually take this wire out and run a wire from there and ground it on the water pipe, and that would get rid of some of that interference for us. Also, we're not using it here, but we also have a place to put a temperature sensor, all on that half of the card. On the other half of the card, that is where we are running our wires for our amperemetric free chlorine sensor. Polarity in this case is, you need to consider the polarity. On the right, we have our clear wire going into the voltage plus, and then to the left of it, we have our black wire going into the negative. The way we have this set up, you'll notice there is 3 terminals there. Our chlorine sensor needs to be powered from our controller. That power that we're sending to that amperemetric free chlorine sensor is allowing that electrolyte that we added in there to charge up, and that electrochemical reaction is now taking place, that we have the wires connected up and we have our controller on. If for some instance we're bringing a milliamp device into it that already has powered, we would use the left half of the terminals. We do not want to put power on power by wiring it into the right side like we're doing here. To the right of that, we have 2 more sets of wires coming in. Those are going to be our milliamp output. If you order a package from us, your milliamp outputs are going to be wired from the factory, and then I'll show you where those are set up in the actual programming of the controller. All the way to the right is our line voltage, so that is where we're bringing power in to power the controller. And in this case, we are powering it with 115 volts. There is also in the DACb an option to get 24 volts. That would be a different controller. This one does not have the ability to wire the 24 volts. We are doing 115 volts. To go back through to show you what some additional options you can bring into the controller, we talked about the digital inputs already. We talked about the liquid potential, the temperature sensor. Here we have two digital outputs. So you have DO1 and DO2. Those would be for frequency outputs. That would typically be going to a prominent pump to control it. We would be sending a contact out, just a closure, to speed up or slow down the pump. The nice things about those is there's two here, and then there's also two up top on the top board. Our prominent pumps, for the most part, come standard with the ability to take a contact into it. So we could just use our universal control cable, bring it in, wire it into our digital outputs, and control directly from here. You also can control with your milliamp outputs, but typically a prominent pump, in order to get milliamp signal into that pump, that is a adder to the price. So we can just do it with the digital outputs, and that would free our milliamp outputs up, and we can just use those as a measured variable instead of a control variable. Going up top, we have an additional milliamp output. So that's milliamp output 3. So we do not wire that from the factory. You have the option to use that if there's something else you would like to output. Next to that, we already talked about our digital inputs. On this top board, we have an additional spot to put a pH or ORP sensor. We're not utilizing that in this case, but it could be added on site. It is unlocked. It is ready to go. Next to that, we have that liquid potential, another place for a temperature sensor like we have down here, and then next to that we have a milliamp input. So we could potentially bring in another ampermetric sensor like total or free chlorine, pure acetic acid, chlorine dioxide, chlorite, hydrogen peroxide. Those are options to go in there. One thing I will tell you is that I can only use one of these options. So if I have an ampermetric sensor up here, I cannot have a pH sensor or an ORP sensor. This is a 3-channel controller. Down here is channel 1 with our pH, channel 2 with our free chlorine, and then channel 3 is up here, and we can only utilize one of those. And then next to the right of that is those digital outputs that I already mentioned. So you have 4 digital outputs that would be for contacting out to potentially a prominent pump. From there, I'm going to put the hood back down, we'll lock it down, and then we'll walk through the process of programming the pump. Programming the controller. Controller will come programmed from the factory. I will show you some of the things that you may need to set up in the field. We have our hood placed back on the controller. We tightened down our screws, and we can go over an overview of the screen here, buttons, and then go into programming. First thing we have is very easy to push buttons here. Escape button is going to escape us out of programs. We're all the way out, so hitting escape's not going to do anything for us. We have arrows for navigation. OK is going to confirm anything that we want to change or enter a screen. The menu button is going to allow us to access the menu screen. We can escape out of it by hitting escape. Start stop button down here. You can notice that our controller is flashing a stop sign. That means somebody has come up here and hit the start stop sign. When we do that, it's going to stop all control. So I'm just going to hit the start button. Next to that, we have our down arrow key, and then we have a calibration key, which is kind of a quick button that gets us to do calibrations. Once you have this controller set up, that's probably the most commonly used thing in here will be the calibration of it. We will talk about that last. Going to hit the escape key. If we look up here, you can see on channel 1, we have our pH. So currently our pH is reading 7.70. Underneath that, that black bar represents that 7.72. The up and down arrows are our limits, so that if our pH went above this arrow or below that arrow, it would give us an alarm. Same thing down here on channel 2, that is our free chlorine. You can see it's measuring in ppms, chlorine free, and then we are using our pH sensor to compensate our free chlorine reading. And then under that you can see we have our high limit, low limit. Those typically aren't used. I'll show you how to turn those off. You'll notice that our bar here representing our free chlorine is actually below our low limit. You'll notice it is flashing. And then down here scrolling, that actually is telling us what error we have. If you don't want to stand here and read it as it's going by, if I hit the OK key, it's going to bring up all my list of warnings. I can click on it. You can see it's warning 1 on channel 2. If I hit OK, it tells me that my limit on channel 2 has been undershot. And if I back out, I agree with that. My lower limit is higher than what my black bar is. So that's what that is. I'll show you how to adjust those limits, or if you prefer to turn them off completely. With them on, I can actually send a signal out to somebody and let them know, hey, we hit a low limit. You may want to come down and look at maybe our chlorine pump has run out of chemical. Also on here, this would represent us controlling it. So our set point for pH is this up and down line. We are above that, so we're not controlling. We're most likely feeding acid. There's no reason, sorry, we're most likely feeding caustic. There's no reason to feed caustic right now because we're at our set point. If we fed caustic, that would keep raising up the pH value. You'll notice it does say pause. That means my flow sensor is not seeing the contact from that float. I'm going to push that down, and you can see that flow goes out, and then we actually pick up and start controlling. All right, so we would be feeding acid at this point at a rate of 38%. So our pump would be sending out, our controller would be sending out a milliamp signal to speed up the pump to get us back to 7 pH. You also see at the very top left there is a card and it says SD. That is an SD card that is underneath this flap. With that SD card I can log data. I'll walk you through the process to set that up. You can also save or load a configuration so that once I program this, I can save the configuration, put it on my computer, and then if somebody comes back here and messes with any of the program, I have a good starting point. I can also take that configuration to another controller that may have a very similar setup, and that gives me a very good starting point. So let's go through some of the menus. First thing, a very helpful tool is if I hit the I key, that will take me to my information screen. From there, I see the raw value of what my sensors are seeing. This is a really good screen for troubleshooting. If you were to call into the Prominent service line, they would most likely want you to access this screen so they can see what the raw value of the sensors are, so they can determine if it's reading correctly. Maybe it's been calibrated too many times. Maybe the electrolyte's ready to be replaced. Maybe your pH sensor has expired its lifetime. It's time to replace that. You also see our current outputs. So we have 2 current outputs set up. One is sending 11.72 milliamps. That's most likely our acid pump, trying to drive down the pH value. And then we're doing 4 milliamps. I'll show you how to look to see what those are set up. We also have 2 relays here set up. Those are our limit relays. One is open and one is closed. And then we have an alarm relay. If I hit escape, that will back us out. I'm going to hit the menu button and we'll walk through each screen here. Most of this is set up for you from the factory if you buy it as a package. If you buy the controller separate and then the sensors and DGMA separate, you would be required to do all the programming. Calibration, we're going to skip by that, but that will be the last thing we do. The first screen after that we come to is measurement. This will be set up. but it's good to go in there and make sure it is set up correctly. So on channel 1 we have pH, so if we go in there, we can go into measured variable and we could change that from pH or ORP or temperature. Those are the only options you have available on that millivolt channel. We want to leave it set up as pH. If we had that potential equalization, that's that liquid ground I talked about, we would turn that on here. We can also detect glass break or cable break with this. You can turn those on or off. Typically, we leave those off when it leaves the factory. I'm going to hit escape to go back. I didn't change anything, so it's going to let me escape back out. If I change something, it's going to say, hey, you changed something, do you want to save it? I would have to either hit escape to not save it or hit OK to save it. Next is my channel 2, which is free chlorine. This will be set up, but it's good to verify. On your sensor that you have installed, it will tell you what the sensor type is. So my sensor is a CLE3, and my measuring range is 0 to 10 ppm. All right, you will get those numbers right off of the sensor. Next important thing is to make sure if we're doing free chlorine, we need to have a pH sensor like we do in this case. And you'll need to go down and turn that on so it's on automatic. We'll program that from the factory for you, but it's good to go in there and to make sure it's actually turned on. An important note is if you change anything in this screen after you've done all your other programming for like your control outputs, once I change something in this screen, it's going to wipe out whatever I have set up for my control outputs. And that makes sense. If we're changing something in here, we should probably go and look back at our control outputs to make sure it matches up. Especially if we're changing sensors from maybe chlorine to PAA. We're most likely not going to keep the same control parameters. So once we make those changes, it will wipe that out. So be aware of that. We also have our third channel. In this case, we're not using it. If you were to go into it, you can see what options you have available for it. So chlorine, bromine, chlorine dioxide, chlorite, fluoride, dissolved oxygen, ozone, peracetic acid, hydrogen peroxide, conductivity. There's numerous options that we could add on to this controller because it is currently open. We're going to back out. We are done with our measurement screen. If we are controlling locally from here, if we have our universal control cable in there going to a gamma L or gamma X pump, for instance, we would need to set up our control screen. So I'll give you an idea of what's in there. First thing we would do in there is we would need to figure out, all right, which channel do we want to control with? Let's, in this case, pH is on channel 1, so we'll set that up to control maybe an acid pump. You can see there's a check mark next to it, so it's already set up to do something. So if I hit OK, the first thing it's going to say is what type of control do you want? I'm not going to go very in depth in this. That would be a whole nother video that would take some time discussing what proportional control is versus full PID control. But you have that ability to do full PID in here. If I were to set up PID with this, I'd have very tight control over my process with the chemical injection. One way would be me for pH putting either just an acid in or a caustic in. Two-way would me be doing both. So maybe I have an acid pump and a caustic pump. Most likely it's going to be one way. pH would be a case maybe where you do two-way control. So in this case, I'll just set up one way. We'll say that we are adding acid. If we add acid, that is going to decrease our pH. And then we would need to go in here and set up the rest of our PID tuning in there. Again, that would be possibly another video, a whole nother time for that. We could also do that for channel 2. If we have a disturbance variable, that would be our water meter. We would go in there and set that water meter up there to add that additional variable in there to affect our control. with that water meter, we can get much tighter control over a process if it is set up correctly. Set point setting, not typically used, but what you could do with that is I could bring in a switch or a signal from the control room into one of those digital inputs. Remember, we have 7 of those. And anytime we switch that switch from one position to another, it would change the set point. Okay. We can also kind of do the same thing with parameter switching. So we can switch from one parameter to the other based off of the digital input. Going to escape out of that. Next is our limits. We talked about those a little bit. You can see I have limits set up for channel 1 and channel 2. So I can go in and I have 2 limits in channel 1. My first one is my undershoot limit. Right now it's set at a value of 6. And so if I back all the way out, that is what this down arrow represents. That is my lower limit of a pH of 6. So if I go back in, if I don't want that on, I simply go in there, go to the function, and I just turn it off. Escape. I can set my high limit. Let's turn that off also. Hit escape. Hit escape again. Go to channel 2. One thing I'll show you before I shut these off is the hysteresis. So the hysteresis is pretty important. It would prevent relay chatter if we have this set up to a limit relay. This is going to be, once we hit that limit, how many ppm below that limit will it have to go before it turns that back off. That will prevent that from chattering if we're right on the limit of that limit. So we can increase or decrease that, so if we're spending time around that limit, it doesn't chatter that relay. Are we going to get an error message? If we do that, right now it's off. And then is there going to be a delay on the limit once we reboot? So once we reboot right now, we'll look at that limit, and if it's by that limit, it's going to trigger that limit. We could increase that in seconds to delay, once we reboot the controller, to delay that initiation of that limit relay. So I'm just going to turn these off. We're not using them in this case, so there's no need to have them on the screen, and I can kind of clean up the screen. If I back out all the way by hitting escape key, you can see those arrows are gone. And then also that scrolling message is also gone because we don't have any limits that are on there anymore. If I hit OK, it's not going to bring up that error screen because there's not currently any errors in the system. I'm going to hit menu. I'm going to go down to pumps. This pump screen would be only used if we set up control and if we're using those digital outputs. That's those pulse frequency, those contacts out. If we are using that, we would go in there and set up what pumps we have. Remember, we have 4 options for those. So you need to know where you landed your wires. We cannot land those wires for you because we do not know if you're controlling. We do not know what kind of pump you're controlling. We don't know what that wiring looks like, whether it's milliamp or a digital. So for pump 1, let's say that is our acid pump for pH on channel 1. So we can go in here. Putting acid is going to decrease that. We would need to figure out what our max stroking rate of the pump is. We could also limit it. So for instance, if it's a gamma X has a max stroking rate of 200. Maybe it's oversized. I don't want it to actually ever get to that speed. I could maybe reduce that to 100 instead of 200. And then what assignment is it? We want it on channel 1 with our pH because it's our acid pump. And we click that and we have that set up. If we don't have any other pumps, I can go in here and actually turn this off so that it is not displayed anymore. So if I back all the way out, you can see that we're paused, so I'm going to push down my flow just to simulate flow. Right now we're at a pH of 8. We should be at 7. So we are feeding acid with our frequency relay at a rate of 50%. Remember, we put 200 strokes per minute. So if I go over to this screen, you can see that my pump is running at half speed, and that's right around 100 strokes per minute. So coming out of that digital output, there is, it's sending a whole bunch of contacts out at a rate of 102 strokes a minute, and that would be speeding the pump up. The closer we got to a set point, that would be slowing down because we'd be getting closer to our set point. We don't want to be at full speed here, or else we'll blast past the actual set point. I'm going to go to menu. Next is our output relays. So remember, we have 2 limit relays that we can set up. And then we also have a alarm relay. I don't have limits set up, so let's just go in there and turn it off. If I did, I can assign them to different channels. So maybe I just want it for channel 2. Maybe I want it for all 3. You can pick those options in here. I'm going to turn it off. We can also change the state from closed or open. So I'm going to go in here and just turn it off. Escape, go down to my relay 2 because I'm not using it. Turn it off and escape. We'll leave our alarm relay on in this case. There is also, you can have some timers in there to do other function. There is the ability to have timers built into this controller. Gonna hit escape. We talked about pumps, we did output relays. Next is your digital input. In this case, our digital input 1. In most cases, if you buy a package from us, input 1 will be set up, and it is set up for our flow. So if we lose flow, it's going to pause our controller. That is for safety. When we pause the controller, if we have any type of control set up, it will stop that pump from running. So we're not feeding acid into a stagnant line of water. You can also make sure it's assigned. We would want it to shut down our control both on channel 1 and 2. That is if we were pumping a chemical from both channels. Right now we are only controlling from 1. We do not have a chlorine pump set up, but we would most likely have that set up if we're doing free chlorine. You can see there is 7 of them there. I showed you where those were on the boards. Next thing is your current outputs. These, remember, we have 3 milliamp outputs. In this case, we are using 1 as a measured variable and 1 as a controlled variable. Let's go to our control variable. It's not set up to do anything, so let's disable it. Okay. Let's go to output 1. So output 1 right now is set up as a measured variable on channel 1, so that's our pH. And you have to set your range depending on what they are looking for back in the control room so that they match up. So right now 4 milliamps is going to give us 2, 14 milliamps is going to give us, 20 milliamps is going to give us 14 pH. So if I back all the way out, we are currently at a pH of 8.06. So if I come down here, that represents 12.0 milliamps. I can send that out to the customer and they could data log it. They could just display it on their screen to see what it is, or they could take that value and then control from their control room. Another really nice screen is the diagnostic screen. In this screen, we can go into a logbook. Remember I said it has a data logger behind this flap. Anytime we do a calibration, it's going to log that. Anytime there's an error, it is going to log that. Data needs to be set up if you want to log the data. So I go to configuration, and then there's a whole bunch of things I can check. Right now, we are measuring the measured value. We are logging the measured value on channel 1. We are also getting the control variable. We are getting the measured value. We are getting control variable on channel 2. Channel 3, we don't have anything on there, so it's all set off. Our digital inputs are being looked at and logged. We are currently making 1 foul per day, and we are logging every 10 seconds. So every 10 seconds, it's going to take a shot of everything that's checked, and then at the end of the day, it's going to take all those shots it took and put it into 1 foul. That foul would be a CSV file that you can take and put on Excel. You can graph it, you can chart it, whatever you want to do with that data. I will tell you that logging 10 seconds is probably a lot of data. If you decide to do that, don't be concerned about the size of the SD card in there. Even logging for 10 seconds, creating 1 file a day, that is still going to be enough size of that SD card to get you years and years of data. So I wouldn't be concerned even logging at 10 seconds of overloading that SD card with too much data. 30 seconds or 60 seconds may be more of a realistic time to log, because otherwise every 10 seconds you're getting a lot of data out of here. Once I pick what I want to log, I hit escape and I want to save it. If I don't save it, it is not going to start logging it. Now that our data logger is all set up, we can escape out of that screen. One of the last things to show you in the diagnostic menu is going to be the simulation. This is a nice feature that we can use during startup. So you can see I can initiate my relays. So my relay 1, I can go on and turn it on. That will change the state of the relay, and you could tell the operator that they should be expecting to see that signal wherever they have it wired. At the same time, we can turn on, if we have pumps going to those digital outputs, the frequency outputs, we can simulate the pump running at maybe 40% speed. Or we can go down, remember we have 3 milliamp outputs, we can go in there and we can simulate a signal and tell the operators that they can expect to see 12 milliamps back at maybe their SCADA or their control room. Nice thing here is if I back out, you'll notice when I go back in, it turns those all off, so I don't have to worry about accidentally backing out of that screen and leaving a pump running at 40% speed. It will turn them off the second I leave the simulation menu. I'm going to escape again. The last menu we have is our setup menu. You can see we can change different languages. We can update, so if there's a firmware update, we can email that to you and you can go through the update process there. There is the ability to put passwords for different users. So if I go in and turn user 1 on and make it active, they're going to ask for what code I want to be, and then there's different profiles, and different profiles allow you to make different selections, allow you to have different access. Please try to remember your code, your password. We do not have access to that, so if you forget it, it is quite a process to be able to reset those passwords. I'm going to turn it off, make it inactive. You notice once I turn user 1 on, it's obviously going to also turn the administrator on. We're going to make that inactive also. If I set up different users and I do a calibration or change something, it's going to log that in the calibration data log portion of the SD card. Another nice feature here, if I go into extended settings, is I can go into the SD card. Sorry, let's go to load or save. I can go in here and I can save the configuration as a text file. So it would give me a CSV file and tell me exactly what's programmed in there. The more important thing is, I would suggest after you're done programming the controller, is copy the device configuration to the SD card. You can just leave it on there. I would also maybe recommend taking that SD card out of there and copying that file into maybe a folder on your computer. That way you have that configuration always there. If, for instance, somebody were to come here and accidentally change a whole bunch of settings, not really knowing what they were doing, you would have that file on your computer. You can load it onto the SD card by going to the bottom selection, and it would load everything you already have configured. If I have a unit maybe at the location down the street that is a very similar setup, I can take the SD card out of this one, take it down to that site, put the configuration on there, and I'm not starting from scratch. And then the very last menu is your general settings, and this is where you can change the date, the time, you can change the date mode format, the units of measurement from Fahrenheit to Celsius. There's a contrast screen, there's also a brightness screen on there, so those can all be changed in the general settings screen. At this point, we've gone through all the menus, we've made sure everything's programmed correctly. If we're doing pumps, we have those set up. Our limits are either turned off or set where we need them to be. We've had water running past our sensors, so the electrolyte is charged. If it's a free chlorine sensor, we've let it burn in for maybe 1 to 2 hours, and we're ready to do our initial calibration. So that would be our next step. Now that we're ready to do our calibration, we can access that by 2 different ways. We can either use the menu key, and we can go to the calibration screen, or I can exit out and we have a shortcut key here that takes us directly to the calibration. When we're doing free chlorine, the pH is extremely important to the free chlorine reading. So we're going to want to calibrate our pH first. So we're going to go to channel 1, hit OK, and this will walk us through the steps of how to do a calibration. First thing, you can see our cursors next to cal setup. So we can go in there and see what the setup is. Right now we're set up to do a 2-point, which is what we're going to do. And we're going to do a buffer of 7 and 10. So our setup is good. We can escape. So once we know our calibration setup is good, down here it says continue with cal. So we're going to hit the calibrate button. And now it's going to tell us what our next steps are. So at this point we would take the sensor out, we would rinse it, and then we're going to stick it in our buffer of 7. Once we have that going, we're going to hit calibrate, and then we're going to look for our signal to stabilize, and we'll give that, it should only take a couple of seconds for that to happen. In this case we're using a simulation, a pH simulator to simulate our signal in, so you'll see it should be very stable depending on how our battery is, in this case in our simulator. So now you've seen our sensor has came in, the signal's stable here. Once we get to stabilize here, we're going to continue with cal. And it's telling me, so my actual buffer was 6.98 pH. And we're going to continue with calibration. Now it's going to tell me to rinse that sensor, so we want to rinse it off. And then it's telling us to put it into our second buffer, which is a pH value of 10. Once I have that all going, my sensor in the new buffer, I'm going to continue with cal. So now that we're in our buffer number 10, we're going to wait for our signal to stabilize here. Once it's getting stabilized, we're going to continue with the calibration. Okay, this gives us just the data on that buffer 10. It actually is seeing 9.93 pH. We'll continue with cal. This will tell us what our sensor quality looks like. We'll continue with calibration. This screen is a very important one. The one thing we want to look at is this right here, our slope percentage. So we use the simulator, so it's a little bit better than what you would expect to see. And a perfect millivolt signal from a pH sensor would be 59.17 or 18 millivolts. That would be perfect. You're not going to see much better than that. But because we are using a simulator, we would not expect to see 60.8 on an actual pH sensor. So at 100% would be near that 59.18 or 17 millivolts per pH. So as we're looking and doing calibrations, this number is gradually going to drop as the electrolyte, the gel inside the pH sensor wears out. That number is going to start dropping. It will allow us to do a slope calibration here until we get down to 20%. Once we get to 20% or below, we're going to get a calibration error, and it won't allow us to calibrate below that. So if we pay attention to this, we should be able to get an idea of when we need to order a new pH sensor, because we don't want to stock pH sensors. They are like batteries. Even if we're not using them, they will start to lose their charge. So we would order one of those. Maybe we say, all right, if we start getting down to maybe 30 or 25% slope, we would order one, and then when it came in, we would install it and replace the one that's currently in there. We have to make sure we import the calibration. If I were to escape from here, we would abort the calibration. So if I continue with cal, it is now successfully calibrated for our pH. Next would be our chlorine. So we can go into our chlorine, and we are always going to do a slope calibration. I would say never do a 0 point unless somebody here from Prominent tells you to do that when it comes to technical services. I would say always do a slope calibration. So we're going to hit OK so that we're on slope calibration. And I have my pH at 10 right now with my simulator. I need to bring that down because remember, pH is in free chlorine are very dependent. So as I bring that pH back down, my free chlorine concentration is going to show back up. Again, I'm using a simulator for my pH in this instance. So it's telling us wait for the measured value to stabilize, which it looks good. We're pretty stable right there. And what it's telling us once it stabilizes is we're going to remove a sample from our sensor. So underneath our sensor there is a valve we can take a sample of. Once we do that, we have the sample. As soon as I hit the continue cal, it locks that number in. So now I have time to go do my DPD test. Once I've finished my DPD test, I got to figure out, here's what it thinks it's reading, and I got to determine what the actual DPD test told me it was. So let's say it was actually 0.90. Let's say that's what my DPD test. In that case, that's pretty close. I don't know if that's necessary to calibrate at that point. There's going to be some error in the DPD test. So I don't know if I personally would recommend changing at that point for a calibration. But if you wanted to, you can see if I hit OK, it's going to allow me to change that. And I can dial it down to 0.9, hit OK, and then continue with cal. And you can see our slope is a little bit above 100%. Same thing with this one. I'm going to look at my slope. That's my important thing. It will let me calibrate down to 20%. So I should be able to, if I pay attention to this number, I should be able to get an idea of when I need to change my electrolyte and membrane cap. So once I start approaching 20%, I better have a membrane cap and electrolyte on hand to do that maintenance. All right. If you have the stuff already on hand, you can wait till you get down to 20%. If you need to order it, I would maybe order it at 30%, and then you would have it on hand to change it. Because if I get below 20, it's going to tell me my calibration is invalid. I'm going to continue with calibrate, and at that point, my pH and my chlorine are both calibrated, and my system is up and running.